Hey everybody, today we're going to be testing out the power output capabilities of this dajunguo S600X. Currently I have a XT60 power connector connected here, directly screwed onto the amplifier board. And I have a custom built 48 volt battery currently sitting at 48 volts. Right here I have my tablet set at 40 Hz test tone at max volume, while I have this amplifier board right here. We're measuring at the subwoofer channel. The frequency is set all the way up, so we're definitely getting 40 Hz, and this is the gain control for the subwoofer channel. I'm just going to go up until we see clipping. Yep, we see clipping. You notice the peak is already a square, and we're going to lower it down a little bit until we see it's a perfect arc. Let's lower it down a little bit. So around 33 volts, measuring off with no loan, we're getting around 33 volts, and it's clean. Calculation, we're getting close to 300 watts. I know that this chip, when it's bridged, is more likely looking for lower resistance loads. So yeah, without further ado, let's connect the load together. Now I got these 4 ohm resistors wired all in parallel, and the final impedance is 2 ohms. I kept the gains the same, so it didn't be messed with. It's still at the 33 volt that we tested before. Now let's do play. 30 volt. Wow. It's cutting out actually. It's going to protection, so let's lower the volume a little bit. Okay, still going to protection, so it's no good. Just keep lowering it down until it's stable. Okay, and see the oscope, it's really dirty. Yep, we go protection again. Let's go down. 24 volt. Okay, now at 23-ish, 24 volt is actually stable. Let's check out the calculations. Times 23 divided by 2 ohms. We're only getting around 260 watts of power. So it's definitely not the 600 watt it claimed is to be. So, and yeah, the amp is kind of warm. That kind of sucks. I was really hoping for like a 600 watt rating, but we're getting, I'm thinking maybe 250 watt to be the cleanest. I don't have a sub to connect to it to test how it sounds at this voltage, but it's kind of disappointing, right? Okay, so 2 of these are removed. Let's check out the specs. Let's keep the gain the same and go play. Check the oscope, that's clean. 23 volt, let's go up until we see clipping. Let's go down to 30. 30 looks good. Divided by 4 ohms, 220 watts. So I have it connected to the right channel, and still the same setup, but with 2 removed, so now it's 4 ohms. And let's start. The tone is also set in the middle, so it's flat as possible. Let's go. Okay, 18 volt, let's go up until it's clipping. We're getting around, I want to make it cleaner. We're getting around 24 volts, 4 ohms. We're getting around 144, also way below the actual ratings. Oh my god, that's sad, but it is the reality. Okay, so finally I removed 3 of the resistors. Now it's just 1 8 ohm resistor in here. Let's see how it does in a 8 ohm load. Okay, so this looks to be pretty good, but not the best. Starting to triangle out and flatline. 26, 27, let's give it the benefit of doubt. 27 times 27 divided by 8. Alright, giving it the benefit of the doubt, we're getting around 80 to 90 watts, which is, whoa, it's so low. This thing is hot now, so let's turn it off. But yeah, this just shows that manufacturers like this, they don't really design the stuff to meet the power ratings as it says on top of here. It is really hot in here. I can feel the capacitors are getting pretty toasty in here because it's right next to the heatsink. That fan is literally choking itself. Look, there's no ventilation here. But like we tested, we're getting around 200-300 watts on the subwoofer channels and we're basically half on the ratings every channel here. So, and plus we're not loading all the channels up. Imagine we load all the channels up, this is gonna even suffer even worse. But yeah, I hope you guys enjoyed this little test, just to find the actual numbers of the power ratings. But yeah, I'm gonna log off.